Okay, let's dive into this. If you've ever written any code, you know that feeling, right? That moment you find yourself copying and pasting the same chunk of code again and again. It just feels wrong. And that's because the whole point of programming is to make the computer do the boring, repetitive work for us. Today, we're going to talk about the key concept that lets us do exactly that: iteration. I mean, seriously, just imagine you needed to print hello 100 times. Are you really going to sit there and paste that line 99 times? No way. Your code would be an absolute mess. And what if you suddenly needed to change it to hello world? You'd have to go back and change all 100 lines by hand. That's not just annoying, it's a total recipe for disaster.
Well, luckily for all of us, there's a much, much better way. Programmers figured this out a long time ago. The solution is a really powerful concept called iteration. And honestly, it's one of the absolute pillars of all programming.
So, what exactly is iteration? It's actually super simple. It's just the idea of repeating a piece of code. And the tool we use to do this is called a loop. You can think of a loop as a simple command to the computer that says, hey, do this thing, and then do it again and again until I tell you to stop. So, why is this such a big deal? Well, for starters, it gets rid of that copy-paste nightmare we were talking about, which makes our programs way shorter and so much easier to read. It's also incredibly efficient when you have to deal with huge amounts of data. But really, at the end of the day, iteration is just a core concept. You pretty much can't call yourself a programmer without understanding it. All right, let's open up our programming toolkit. The first tool we're going to pull out is something I call the counter. Now, in proper programming terms, this is what's known as a count-controlled for loop, and it is perfect for one very specific job. The rule here is dead simple. If you know ahead of time exactly how many times you need to repeat something, whether it's 5 times, 100 times, or 1,000,000 times, the for loop is your best friend. It's built for precision. So let's look at a classic example here with some simple pseudocode. This little for loop is designed to print the numbers 1 through 5. Now, the syntax might look a little strange if you've never seen it, but trust me, every single part has a job to do. Let's break it down. Okay, here's how it works. That first line, for I equals 1 to 5, that's the setup. It basically creates a temporary little counter, we're just calling it I, and tells it to start at 1 and get ready to go all the way to 5. The line that's indented, print I, that's the main event, that's the code that gets repeated over and over. Finally, next I is the command that tells the computer, okay, you're done, now add 1 to I and run the action again. It just keeps doing that until I hits 5, and then the loop knows its job is done. See? Simple as that. Okay, the for loop is great when we know the exact count. But what happens when we don't? For that, we need a totally different tool. Let's call this one the guard, because it decides whether to repeat based on a condition. Think about it. What if you have a program that needs to ask a user for a password until they get it right? You have no clue if it's going to take them 1 try or 50 tries. This is where condition-controlled loops are essential. They don't use a counter, they use a question, a condition that has to be either true or false. So our first type of guard is the while loop. You can think of a while loop like a really cautious bouncer at a club. It checks the condition before it even considers letting the code inside run. In this example, it's asking, is the answer variable not equal to yes? As long as that's true, it'll keep running the code inside that asks the user for input. Now, this is a really, really important detail to remember, because the while loop checks the condition first. If that condition is already false right from the beginning, guess what? The code inside the loop will never, ever run. Not even once. The program just skips right over it. Okay, on to our second type of guard, the do until loop. Now, this looks kind of similar, but its whole philosophy is completely different. This loop is more of a do it first, ask permission later kind of deal. You see the structure here? The do keyword is right at the top, then comes the action. And the until condition is way down at the bottom. This structure means a do until loop is guaranteed to run its code at least 1 time. After it runs, then it checks the condition to see if it should go back and do it all over again. This slide right here lays out the difference so clearly. Let's just walk through it. A while loop checks the condition before running. Do until checks it after. A while loop keeps going as long as its condition is true. A do until loop keeps going until its condition becomes true. It's a subtle but really important difference in logic. And of course, the big one. A while loop might run 0 times, but a do until loop will always run at least once. So, we've got 3 tools in our toolkit: for, while, and do until. The big question is, how do you know which one to grab for the job? It's actually a super simple decision-making process. The very first question you should always ask yourself is this. Before this loop even starts, do I know exactly how many times it needs to run? If the answer is a clear yes, I need to do this 10 times, or I need to process all 50 items in this list, your choice is easy. You just use a for loop. It's the perfect tool for any task where you're just counting. But if the answer is no, you don't know how many times it's going to run, then you've got a follow-up question. And that is it absolutely, positively essential that the code inside my loop runs at least one time? And there's your answer. If that code must run at least once, like prompting a user for the first time, then you're going to want a do until loop. But if it's possible the loop shouldn't run at all, maybe the condition is already met, then the cautious while loop is the right way to go. Now, before we wrap up, let's talk about a few common mistakes people make. It is really easy to mix up while and do until, so keep that comparison in mind. The most dangerous mistake, though, is creating an infinite loop. That's a condition that never becomes false, and it'll just cause your program to freeze up or crash. And finally, always try to use the right tool for the job. Don't try to force a for loop to work when you don't know the number of repetitions.
All right, I know that was a lot of information, but it all really boils down to just a few key ideas. So let's do a quick recap with a final cheat sheet just to make sure this stuff sticks.
So here's the bottom line. Iteration is just a fancy word for repetition. For loops are for when you can count. While and do until are for when you need to check a condition. And the big difference between those two is all about timing. While checks before and do until checks after. If you can remember these 5 points, you've totally got the fundamentals of iteration down. By understanding these simple tools, you've literally unlocked the ability to make a computer do thousands or even millions of things with just a few lines of code. You've learned how to make your code do the heavy lifting for you. So the only question left is, what amazing things are you going to build with that power?